Well, hello, welcome to a video for general science. In this video, we're going to be discussing electric current and Ohm's law. Right above, you see the formula for Ohm's law. That's voltage equals current times resistance. We'll take a look at that equation in greater detail at the end of this video. First, let's start off with electric current. Electric current is a continuous flow of electric charge. So we're talking about the movement of electrons through a material. Okay, and we measure this current in amperes. So there's two types of currents that we're going to discuss right now. The first is alternating current, or actually the first will be direct current and then alternating current. This you know as AC and DC. AC alternating current and DC direct current. Let's first talk about direct current. Direct current, what you have here above, magnified view of copper, if you will. And we can see the electrons moving inside of copper. So that line you see there is a copper wire with its electrons. And what happens is that these electrons flow in one direction, which is where direct current gets its name. It's in one direction. Direct current is mostly used in batteries, okay, where you'll have a voltage difference. On one end of the battery, you'll have the electrons flowing towards the positive end of the battery, and so you have one flow, one directional flow, direct current. This type of current is best in short distances. It's most efficient in short distances for the fact that the electrons carry that charge throughout the entire pathway of the wire. So this is best in short distances. So when you have a flashlight, something small, tiny motors, and then you have power lines. Not quite as efficient with power lines though, because power lines are quite a bit longer, they cover a longer distance, and direct current is not as efficient. Okay, you have a lot of loss of power throughout the entire distance that this charge is traveling. Okay, so what do I mean by that? Try to imagine taking a hot coal from a fire. So you take that hot coal and you're transferring it over to another fire or another area, if you will. So the greater the distance that other area is, in time, that coal that was red hot at one point is going to slowly lose its heat and it's going to go back and cool off to its original state. Likewise, in electrical charge, if you have an electron that's traveling the whole distance, then that electrical charge is going to lose some of that charge throughout that distance through friction of the copper wire or whatever means that you're traveling through. Okay, try to imagine also transferring, let's say, a letter. Let's say I asked you to take a letter and we needed to get this letter 1 mile away from where we're at right now. Well, if we had a line of 100 students lined up throughout that mile and we passed on that letter from student to student, imagine when the letter got to you. And imagine the amount of distance that you would have to cover till you got to the next student. You wouldn't have to travel very far before you got to the next student and transferred that letter. Well, that letter would be like an electrical charge in AC, actually, an alternating current. But imagine if I asked only one person to take that letter that 1 mile. Well, that one person would be pretty tired after that 1 mile. So this is where Nikola Tesla comes in, an alternating current, where he created a more efficient way of passing current through material. So going back to my example of a student carrying a letter 1 mile, well, if I had 100 students helping that one student, then the accumulation of all these students lined up in a row, then each person would not be very tired after taking that letter 1 mile distance. It would be a much more efficient way of taking that letter from one place to another. Likewise, the electrons in the copper wire, they alternate. They alternate in carrying that charge. So what will happen is that you'll have these electrons that will carry the charge and then they go back. They go back to their original spot. And then the next set of electrons will carry that charge and so forth. And that just continues back and forth, back and forth. And because of alternating current, you now have a much more efficient way of taking a charge where there's very little, if any, loss of charge throughout the entire pathway. And you can actually carry a charge at a much greater distance using alternating current. Okay, so we move on now to our Ohm's law. that equation I was telling you about at the very beginning. So V equals I times R. Your V here equals volts, which is measured in amps, and your I is the current and measured in ampere, and then your resistance, which is measured in ohms, which you have the omega, the Greek omega sign that represents ohms, or the resistance of a material. The other way you can look at this equation is I, current, equals V over R. So it's a proportion of your voltage difference divided by the resistance. So if you have a greater resistance, if the material is greater in resistance, then you're going to have a lower current. Okay, so just imagine a river. If the river is smaller, if it's more narrow, if it's like a creek, you're going to have a low current. But if you widen that river and make it larger, or if you thicken the wire, if you will, then you'll be able to carry a lot more current. But if you have a thin wire, then you're going to lower your current. And that's what that resistance means. That resistance is that you're doing something that would increase the amount of resistance in the material. Okay? So again, increasing the resistance, increasing the denominator number would decrease the overall number. It would decrease the current that you run through a material. Now inversely, increase the voltage difference, okay, increase the amount of water flowing through that river, then naturally your current is going to increase. But if you decrease the voltage, then your current overall will decrease. So just think of it in mathematical terms. If you increase the value of the numerator, then the overall value of the number will increase. And likewise in the denominator, the bigger the denominator gets, the smaller it gets, the smaller the overall number gets. Okay, so mathematically it makes sense, and physics-wise it also makes intuitive sense. Okay, so in a future video I'll do some problems working this out and hopefully giving you a clear view of this equation and how it works. Okay, well that does it for this introduction, this lecture of electric current and Ohm's law. Good luck in your studying.